a solution of 1.0 molar hydrogen fluoride, and we're going to compare it to a 1.0 molar hydrochloric acid solution. Now, we're looking at this from the point of view of pH and pOH and hydronium ion concentration and hydroxide ion concentration. First thing off, hydrogen fluoride is a weak acid. So when it goes into water, it does not fully separate into hydronium ions and fluoride ions. If the concentration of the hydrofluoric acid is the same as the concentration of the hydrochloric acid, they theoretically should have the same pH, unless one is weak, and hydrogen fluoride is a weak acid. So that means hydrochloric acid will have a much lower pH than hydrogen fluoride of the same amount. So we know that this is not going to be the same pH. The hydronium ion concentration in solution should be also smaller than that for hydrochloric acid because a lot of it is still bound up in the hydrogen fluoride. So that one should not be correct. We can check this by quickly doing, for HCl, we know the pH will equal negative log of our 1.0 molar, which means that that pH will actually end up being 0. Now, since we also are going to need to know our pOH for hydrochloric acid will be 14 minus our 0, that's right here, which is 14. The concentration of hydroxide ions will be 10 to the negative 14, or 1.0 times 10 to the negative 14 molar. So that's the information for the hydrochloric acid. For hydrogen fluoride, we know that it's a weak acid, so H2O with hydrofluoric acid results in our hydronium ion plus our fluoride ion, and that's an equilibrium. We have a Ka for that at 3.5 times 10 to the minus 4. To figure out the amount of hydronium ion, we're going to set this up as Ka is equal to the H3O plus and the F minus 1 over the HF, like we do for any weak acid. That's 3.5 times 10 to the minus 4, equaling X and X and 1.0 molar. With some rearranging and solving, we know X will end up equaling 0.018708 approximately, which means that is our H3O plus concentration. That makes our pH equal to negative log of 0.018708, which means you're looking at 1.73. So again, we have confirmed that the pH is not the same. We can see the hydrogen ion concentration is not bigger than that of the hydrochloric acid. To get the pOH, we're just going to do 14 minus the pH, which is 14 minus 1.73, and that results in 13.872, and then we can anti-log and get to our hydroxide ion concentration, 10 to the negative 13.872, and we end up with 1.5 times 10 to the minus 14 molar, which is a little bit bigger than the hydroxide ion concentration for the hydrochloric acid. So let's look at our pieces of information. A higher pOH, well, that's 13.872 as opposed to 14, so that one doesn't work. A higher hydroxide ion concentration than that for the HCl. Well, that one is true. That one we can see because 1.5 times 10 to the minus 14 as opposed to 1.0 times 10 to the minus 14. And there's no way that it has a lower pH than hydrochloric acid, which is sitting at 0, versus the hydrofluoric acid at 1.73. So our correct answer would be this one.